Hello, my name is Moura Santos and I came from Técnico in Universidade de Lisboa, from Lisbon, and I came here to talk about and to share my experience of integrating Mathematica into MOOCs.
Well, thank you very much for your presentation, and thank you the organizers for this opportunity to share. I'm going to talk a little bit about the background. This is not all of the answer of who I am. Who am I? Because I am also a researcher, I'm a mathematician, and I work at the Department of Mathematics in this institute. So this is the main building of the Technical Institute in Lisbon. Maybe I will show you. So I will talk more about the teaching there, and for instance, this is one of the, maybe I close this one. So this is a classroom. So this is for lectures, and usually I'm there and I talk to 200 students of engineering. So this is a school for engineering, different specialties. And when I teach, I use a lot of Mathematica in my teaching. So usually I teach linear algebra. So you see there, so this kind of, I teach the basics first, and then I use the basics to go through Markov chains, and at the end of linear algebra course, they are supposed to know how to calculate the steady state vector for a stochastic matrix, and how Google PageRanking is working. And I also teach a lot of vector calculus, so I use also the visualization tools of Mathematica. So they are used to see at the lectures, so 3D graphics, and to use them to answer the quizzes. I will show you in a few slides. So I teach how to use Mathematica, for instance, to calculate the power of a matrix, and to see if the matrix, it's a stochastic matrix. At a certain point, the power of the matrix shows the steady state vector in columns. I use the columns. So if I put here some more power, they are approaching. So matrix form. Okay, so this is a way to find steady state, but maybe you know this. And I want them to use the Mathematica to calculate different things. So, but the aim of my talk is to talk about MOOCs. And I don't know if somebody in the audience already signed for one? No? Only one? So what is a MOOC? So the MOOC stands for massive, in the sense it's that you can sign in for a course. So the course, so stands for Massive Open Online Course. So the last word is for course. So a massive course means that you can sign in for free, and is not limited. So there are thousands of participants in a MOOC. In the first MOOCs, it's a huge movement, let's say, in teaching, or in that began at 2008 with Coursera and edX. So these are platforms that are the front end of MIT, Stanford, Harvard. And so the first MOOCs were attended by thousands of students. Then the open is also in this sense that you can access them from everywhere. Well, the assumption is that you have internet. You have a good or at least an internet connection that works more or less. Then all the contents are online. So you don't have, so the media, the online contents are by means of media channels. This means that you have lectures, tutorials, and so on, by like video. Maybe you are aware of MIT OpenCourseWare. So this is kind of these videos, but they are shorter and without so the audience, it's online. It's sitting somewhere in the world. And then the course means that at least the courses that I'm interested in are in STEM, so in science, technology, engineering for engineering topics, and maths and mathematics. So what this means that you have these educational contents in different formats, videos. You can have PDFs, readings, writings. And you do have demos and simulations, and then you have the evaluation. So you have the quizzes, and some of the MOOC movement evolved, and nowadays you can have a certificate for a MOOC. So if they have verified certificates for people who attend the MOOCs and have success in, let's say, more than 60% of the quizzes. So there are local little quizzes and then more general quizzes that simulate like a final exam or test. And they are structured as a learning sequence, most of them. Some of them are totally open all over the year, but the ones that I want to talk about are in time, so you must sign for them at a certain date, and they are running for 4 weeks, the little ones, the shorter, and for 8 weeks, let's say. And I want to show you a teaser for one of the MOOCs of at EPFL, maybe you know it. It's Swiss. So this is a MOOC about the introduction of astrophysics. So this is the teacher. He is going to maybe we see only the. So remark all the images. So he is in the studio with the chroma key, and the scenarios are now is running a simulation. So this is not the real thing. This is only a numerical simulation that then is going to show. Here is the simulation of the formula of the organization of a galaxy. And then they have this kind of, you see the slides? This is like a simulation of the whiteboard or the blackboard. Then if you, so he's speaking in English, in French, sorry, and the subtitles are in English, but these are special ones. These, if you freeze, maybe I don't do it now, but if you freeze, you can go till the moment of the video when he's saying some words. And there is the staff on, so this is the studio, this is the EPFL studio. Now he's talking about the prerequisites for the course. So he's going to talk about a MOOC for the second year of engineering, so for physicists and engineers at EPFL. Okay. So what so maybe I escape from here. I will come back to the slides. No, sorry. This is something. Sorry. He's going. Okay. Thank you very much. Oh, what's the problem?
Something in your notebook, because you're in an untitled notebook now.
Oh, yes.
You changed something behind the back. Probably you have to close this first. Yeah. Okay.
Okay, so I wanted to show you the teaser because the videos in MOOCs are very important. And first of all, at my university, technical institute, we decided to go to this, to join this MOOCs movement and to begin to make some MOOCs. The first ones for the horizontal courses. So this means linear algebra, vector calculus, mechanical and optics, electrodynamics, so electromagnetism. And we wanted to make stimulating contents for this kind of MOOCs. And then, first of all, we analyze the methodology and study the kind of videos that are needed for a MOOC. So we came up with these 4 categories, let's say, of videos. So you saw a teaser. The teaser is commercial. It's come to us, towards us, and follow our MOOC. And then you have these 3 kinds of videos that simulate. The introductory videos is only about all what you are going to see on this MOOC and how it's going to work. So you have in a release, in a week, you have the release of the video lectures and the tutorials, the simulations, and then a quiz. And you usually have like 2 weeks to complete the quiz, but there is a new release in the second week, new materials, new contents, new simulations, and other kind of contents, and then a quiz. So you have the expository videos is like lectures. And then you have the tutorials / laboratories. If you have a MOOC in physics, in general physics, you have this kind of remote labs or different kind of labs. So we analyzed and we did a lot of, so maybe I come. First at all, we characterized the kind of videos that we can find, and maybe this is not so important now. And we analyzed the average shot length for a video. We saw the teaser for this MOOC of Introduction to Astrophysics, and we did this average shot length analysis. This is like in cinema, so videos are a little bit like cinema. So what kind of shots do you have? We have this kind of archive images. Then we have here this kind of molecular thing, and then the titles, and then the teacher. Yes, you have the teacher, and beside it's like a blackboard or a whiteboard, and something can happen. Like here, you have this as a picture, or you can have like the whiteboard explanation. And we conclude that for instance, in a teaser, the dynamics must be, these are so for a teaser, for this teaser that I showed you, there are 16 shots. The first ones are archived, these little pictures that you see, and then it's teacher, and then images, and like the whiteboard. The whiteboard is a digital, is a table, it's like a tablet, a big one, yes? And this replaces the usual whiteboard. And so you see that the dynamics of a teaser, it's not bad. So this was a teaser for that lasts 2 minutes and something, yeah? And you must be dynamic in this kind of teaser. But not all contents are teasers. So, for instance, what do I need for? Presently, I'm constructing a MOOC on matrix dynamics. So I want to have lectures about stochastic matrices and to explain from the start, let's say, from not assuming that the participants have many knowledges about algebra of matrices, but at the end I want them to go, so everything it's in Portuguese because the contents will be in Portuguese with English transcripts, subtitles, and the topics, so these are the weak topics. So the first are going to be classical models for these transitions for Markov chains. So the classical and standard model for 2 states, and the construction then of more elaborated models with 3 states or more, then can apply at the end to the page ranking matrix. So. Well, at first I wanted to use the presentation mode, the Mathematica presentation mode, but this is not allowed for this kind of content. So I make everything in PowerPoint. It's the templates are in PowerPoint. So, but in a way, I want to use many of the features of Mathematica. So, for instance, the PowerPoints are needed because you don't. This kind of slide that scrolls, it's not allowed in this kind of MOOCs. You have only, it's like you have the whiteboard one, and then you flip for the second. So this was my first, how to say, difficulty in the way. But anyway, for instance, this is a slide that you can use, and you have this prepared, and then in a digital table in the tablet you fill in. So I'm going to model this kind of standard model, put numbers, and write equations. So this is for the writing space there. Yes, this is below this transition matrix. But then I want, of course, to use demos that are already done. So I want the participant and the student to know how to construct code and use the code. Well, maybe not all the code, but sorry, maybe I must. Okay, and to end up with a demo where they can have these sliders, manipulate things, these wonderful things that Mathematica uses. And below that, they can have the model, the figures, and then they can have also the calculations in below. And in a MOOC, you can put these kind of contents online and to download. So if someone is participating participating in a MOOC, he can download all the CDF. So this is like a CDF. Yes, please?
When you put them online, do you embed them in an HTML page?
Yes, yes. So this is the difficulty, for instance, is yes, because also the user can download, but he must have the CDF player in the computer of his individual computer. Yeah. This will be nice to have the Mathematica inside the MOOCs. So it's what I want to say. And I also have, for instance, if we have a tutorial video, so this is like the same model, but now you have the sun shining and then the clouds, and you ask the participant or the student. So make a long-term forecast for this region. And if you put some numbers then, some percentage of a sunny day after a sunny day and a cloudy day after a cloud day, and then you make a quiz, yes? And so I want this kind of things running on a MOOC also. So if you put, I think, the running simulation, you can prepare. It's not working. Maybe not. Something was. Oops. So I can prepare a running simulation for helping the participant to work out this kind of tutorial video. And after the tutorial, I will put a quiz. So quizzes are very important in the MOOC. For instance, here I put, so this is a long time work with Mathematica, and I use this kind of questions. So these are multiple choice or not so much, because you see you can have a question and then different statements, and the student must see if it's true or false, each of one. So I do assessment of my students, of my on-campus students, with this kind of quizzes. And I want also to use these quizzes that goes online. So this is generated with one notebook. So it's code, Mathematica code, and then it generates an XML that goes online. And in our LMS, so in our learning system of the faculty of the university, each student receives an individual quiz, and they have this for assessment. And this counts for a grade, for linear algebra course or for a vector calculus. So I want to use this kind of already worked out. I'm not sure if now. Yes, now it works because maybe I can log in. So this is more or less the aspect of a MOOC in a platform. But let's say if I can log in. Yes, so this is already a prototype. You see we have this courseware, where are the contents. Then the course info, it's for staff only. And then we have, so in a MOOC, you can have discussion, you can put questions, and they have the staff answering these questions. This wiki can work or not, it's up to the teacher or and the student can see the progress. Progress means if you put some quizzes, so you can see here the grades. So, but coming back, so here, for instance, so I can embed in the MOOCs platform this is our technical platform, I can embed this kind of quizzes. So till now, the MOOCs even in maths or physics have quizzes, but in one quiz, the question it's only one for everybody, for these thousands of students. And here, each one receives a different question. So if you want to make more certificate evaluation, I think this is going to work better.
And that's implemented in Mathematica?
Yes, this is implemented in Mathematica. Sorry? You mean this? This is the browser. This is a problem in the browser. This is in Firefox. I'm using the Firefox. If you see it in Chrome or Safari, the breaks are okay.
Are they formatted as MathML?
Yes, yes. And we can have also quizzes with animations. So here it's like a parametric function. And here it's multiple choice. Only one is correct and the others are not correct. See, this is already embedded in the platform, but it's still the prototype. And I'm already finished. So I think MOOCs, at least by MOOCs, should use many Mathematica features. So I want them to have real-time computation, simulations, these quizzes that are graded automatic. So, and the short videos that I must do with PowerPoint must also integrate when I can make the PowerPoints and then because this is very much, I go into a studio and everything it's very prepared. I must go there and I have 10 minutes to do my talk, let's say, and this is teaching, speaking, then the tablet, and then the simulation, and everything must be prepared and embedded in the video. So you see more or less the length of the videos. So if you want a lecture, it will be not more than 12 minutes long. And for a tutorial, I mean more exercises, it's 7 minutes. These are more or less average numbers. And I want also that these all simulations, demos, and so etc. will be available for the participants. And I think this stimulates further use of Mathematica. Because I already did some courses, and for instance, linear algebra of Austin, Texas Austin, it's with MATLAB. Then if you go to the plasma physics in FFL, MATLAB. So I think it's time for Mathematica to be integrated in MOOCs, and I think this is nice.